In this video, I just want to wish you all good luck on the AP tomorrow, and to just very briefly overview what we've done this year and what's on the test, what's on the AP. The course has two major content areas. Java, obviously, but in Java, a lot of work with lists and loops. I'll come back to this. And the fundamentals of object-oriented programming. So we covered how to define classes, how to make objects of those classes, what constructors are, the fact that you can have overloaded construction, multiple constructors, what fields are, the variables that are common throughout the class, what local variables are, the variables that are defined within blocks of code, usually within a method, but it can be any block of code just defined by a set of braces. Methods, the types of methods, how to pass parameters to methods, return types of methods, void, int, double, etc. Methods can return objects. Excuse me. Methods can return lists. Parameters, passing things into methods. Then inheritance, nature of inheritance with superclasses. And then the superclass of all is the object class, which I talked about in my last video. The subclasses, how superclasses and subclasses relate, how subclasses can override methods in superclasses, or they can use the method in superclasses, how to use super to call the methods of the superclass from a subclass. The fact that a superclass's fields are not directly accessible by a subclass, but need to be accessed via accessor and mutator methods, right? I've spent a lot of time on that. Polymorphism, that you can define a list, usually, as to hold a superclass type, but the elements of that class, of that list, can be any of the subclasses of the superclass, right? So, and then polymorphism means that Java will, as it's working on each of those subclasses within the list, as you process the list, it will know which subclass it's working with, and therefore will call the appropriate method that belongs to that subclass. Okay? Abstraction, the idea that it's often useful to abstract out common functionality and put it in a superclass that's either an abstract class or and then you can do subclasses from that. We went over this multiple times, most recently in the code for the 11s game, and then we modified it so that we abstracted out the code that would work for a variety of different games besides 11s, similar games, but different. And then interfaces, right, which are just a sort of a super abstraction in that they just say that any class that implements this interface must have fully non-abstract methods for each of the methods that are listed in the interface. So the most common interface that we've run into this year is the list interface, which you've seen over and over again, right? So let's go back to lists, because in terms of the data structures, that's the heart of the course. So three types of lists. Arrays, which are like the granddaddy, the super class of lists within all programming languages. They were there first. then array lists, which are just sort of objectified arrays, fully functional object, a fully functional class with additional functionality, but they're backed up by arrays. Remember, we looked inside of array lists, and what do we find? We found an array. And then strings. And strings are simply a list of characters, and they are also backed up by an array. That's where the characters are stored, in an array of characters. Okay? So it all comes back to primitives. Primitives are at the heart of programming. But we build on those with increasingly abstract structures, which allow us to do things more easily. Okay? Just one more thing on lists, right? We have two-dimensional arrays, which are simply, right, lists of lists. So instead of having a primitive or an object in this cell, what do we have? We have another list, right? And so in each of these cells, we have another list. And this can actually, you know, you can get very Baroque with this. Baroque as in the art style Baroque, right? You could have each of these lists could in turn consist of lists. Right? The elements could be lists. And each of those could have lists as their elements. And you see what I mean by Baroque, right? And these could have lists as their elements, and it gets crazy. But gives you lots of flexibility. Okay, a few other things about lists, right? They always start with 0. Arrays, array lists, strings, they always start with 0. Don't forget that. You know that, right? The size or the length, right? Different arrays uses length without parentheses to tell you the number, or actually with arrays, it's the number of cells. Array lists use size with parentheses because it's a method call. That gives you the number of elements in the list, the array list. And strings use length with parentheses. That gives you the number of characters in the string. Right? Those all give you whatever that number is, the last array position that's actually used is 1 less than that. So if your size of your arrays is 11, if length variable of arrays contains 11, it means your last element is 10, right? It's always 1 less. Because you're starting counting at 0. And finally, the types of algorithms that we've done this year, right? Sorting of lists. We spent a lot of time on sorting of lists, finding things in a list, binary search, right? Splitting the list in half and then splitting the sublist in half, and so on. Working with a list. All the work with the card game involved an array list of cards, right? Deck. All the work with the pictures, two-dimensional arrays of pixel objects, and then all the work with strings, or just working with lists. So on the test, on the AP, right, you can be sure that almost all of the questions will involve doing something with a list, traversing a list, having a list of values that are entered and you have to do something to them. But it's all about lists. And then the loops, right, we went over, you have a bunch of loops available to you. You have the while loop and its variant, the do while. Okay, you have the traditional for loop where you do the starting value, stopping condition, and the increment. And you have the for each loop, which is used for an easy way to process through all the elements of an array list, or an array, or a string. So those are the three looping structures you have available to you. And finally, the last thing I want to mention is recursion. Right? So recursion is when a method calls itself. Recursion is an extremely powerful tool, and I know some of you like it a lot, and I understand that, right? It is when you get the hang of recursion, it's almost like magic. But you know, for most list-related tasks, recursion is not necessary, and in fact, because of the overhead of using the stack with recursion, as your lists grow bigger, that overhead can really hurt you. So in most cases, one of the loops is a better approach for working with lists than recursion. Remember, with recursion, the key is that you have a stopping condition at the start of your recursive method, and that when you call the recursive method, you are approaching the stopping condition. So if your stopping condition, say, is some variable, say x is less than 0, then you better make sure in the stopping condition that, in the call to the recursion, that x, first of all, starts out above 0, and that x in the call, in the recursive call, decreases. Right? If x increases in the recursive call, you get you move away from the stopping condition, and your program will crash. Okay. Watch out for the takeoffs and landings. By that I mean the one-off problems with working with lists, right? Going one too far, either in either direction, or not going one too few. Either is possible. Just be aware that that's something that's always a little tricky, and you have to make sure that you check for it. And that, I mean, there's other stuff. There's all the details. There's the if statement. There's lots of other little things. But I think this is the key. These are the key elements. You need to know about lists. You need to be very confident working with lists. You need to know have your loops down totally, right? So you're comfortable with each loop type. You have to know the types of lists, and the fact that two-dimensional arrays are lists of lists, right? And you need to know your object-oriented programming features. Okay? So if you have any last-minute questions, please don't hesitate to get in touch. Happy to answer them. And again, good luck tomorrow. And I hope you all, sounds crazy to say this, but I hope you all enjoy the experience. It can be a fun thing if you're prepared. Okay? Take care all. Talk to you after the test, unless you get in touch with me. Okay? Again, good luck. Get a good night's sleep. Thanks.